Okay, we're going to look at the range of arc Z given that Z lies on a perpendicular bisector. So an example here is that Z lies on this perpendicular bisector, but first you got to put it into the form of Z minus Z1 equals Z minus Z2 modulus. So then it's Z minus 1 minus 2I equals Z minus 3 minus 6I. So this is your Z2, this is Z1, and that's minus. So it's going to be here plus. So the Z1 here is at 1, negative 2, and Z2 here is negative 3, 6. So it's over there. And then you join these two intervals, you find the midpoint, you find that line there, which is a perpendicular bisector. So this is 1, negative 2, this point Z1, this point Z2 is negative 3, 6. So the gradient of M1 then, it's going to be 6 minus 2 on minus 3 minus 1, which by the way is minus 2. And so M1 then is going to be a half. So which means that if you take this as my angle, yes, that angle is tan inverse of a half. So that means that if you take the argument of that, I have to draw another diagram to show you, is that here is my line, and my argument can range from anywhere from there to there to there to there. So imagine if you have this infinitely away, so that this is going to be like parallel to it, then you'll get that one there. So this is parallel to this. So this will be theta, and that will be theta, which is tan inverse of pi on 2. And then imagine another one that's infinitely down that way as well, which is also going to be parallel to this. So that's going to be theta over here, which means that your argument, the range of argument, there's two ranges of argument. There's one that's greater than this, because that's going to be, you never get this. You get closer when you get to this, but it's going to be greater than that. So because if you take anyone there, that's going to be greater than that. And then this is your other extreme when you're here, when you cut that. So for this bit, for the positive bit, your argument then is going to range between of a half, never equal to, by the way, and it's going to equal to pi when it's over here. Your positive one, your negative one rather, is going to go from this, which is the biggest negative one, to the smallest negative, which is negative pi. And that is going to be, if that's theta, which is tan inverse of a half, that's going to be, in terms of the size of it is pi minus tan inverse of a half. And that would be, in fact, tan inverse of a half minus pi less than arc z, never equal to as well, and then less than negative, sorry, my mistake, not this one. It's actually negative pi less than arc z less than tan inverse of a half minus pi. So in fact, this is quite a difficult one. You have two ranges of arc z, this one and this one. So your arc z, just to recap, given that z lies on this perpendicular bisector, the range of arc z is actually going to be, the negative bit is minus pi is less than arc z, less than tan inverse of a half minus pi, or tan inverse of a half is less than arc z is less than or equal to pi. And that is your answer for this range of arc z, if given it's like perpendicular bisector.